Hi, my name is Samantha Berman, University ID number 205304608. So for problem 2 on the midterm, this one was hard. So first I just started by calculating rho of the liquid in the pipe using its specific gravity. And then I used a diagram and I identified 4 points of interest. So the first point of interest was where the manometer first connects with the pipe at the larger radius of 105 millimeters. The second point was at the first liquid water interface within the manometer. The third point was at the other liquid water interface inside of the manometer. And finally, the fourth point was at the top part of the manometer, at the interface where the manometer again reaches the pipe of the smaller diameter. So then I defined the pressure at point 1 relative to the pressure at point 2 because they're the same liquid, they have the same rho, the only difference would be their height. And using, I identified the axis y equals 0 to be at point 1. So then point 1 was equal to point 2 plus rho gh of between the 2 points, point 1 and point 2. And then similarly, point 3 and point 2 could be related because they were the 2 points on either side of the water within the manometer. And then finally, point 3 and point 4 were in the same liquid and they were at the same height, and so they would have the same pressure. Then I identified a few assumptions. So first, that there was a steady flow within the pipe. It's an inviscid liquid and it's incompressible. So then using those, I was able to use Bernoulli's equation between point 1 and point 4, which again, point 1 was they were both within the pipe. Point 1 was at the part of the pipe with the larger diameter, and point 4 was at the part of the pipe with the smaller diameter. And then I identified a few, so givens again, so point 1 was at y equals 0, and point 4 was at y equals 0.6, which was the given height of the manometer. And then I solved for the difference in velocity of the water at point 4 versus point 1. So v4 squared minus v1 squared. And then using the continuity equation of q equals a1 v1 equals to a4 v4, so it's the same at all parts of the pipe. I just rearranged it for v1, which is equal to v4 times a4 over a1. And so I got a value using the given diameters. I calculated the area of a4 and a1, and then I plugged that value of v1 back into this equation from the result of the Bernoulli's equation and just simplified for v4, and then plugged it back into the q equals v4 a4 and got the flow rate.